continue our good work on number system. We have seen how to convert number system from base 10 to other base, from other base to base 10, whole number, the conversion, fractional number, conversion, a lot. Now we want to look at the basic operation. Anytime I mention basic operation, what comes to mind is addition, subtraction, multiplication, and division, right? These are basic. Before you now talk about exponential, talk about radical numbers. So now, how can we add binary number? Let's start with binary. Don't forget, binary is base 2. And base 2 consists of 0 and 1. Remember? So this is very important, which means the highest number we can see is 1. Now, let's come to this place. The first question, it says, we should add this guy with this guy. So we want to add 1, 1, 0, 1, 1 in base 2 with 1, 1, 0, 1, 1 in base 2. But now, addition. Don't forget, when we are working with addition of whole numbers, that was in base 10. Which means when you add number and it's more than 9, we have to write the units and keep the tens, right? Exactly what happened. Let's look at it. 1 plus 1 is what? Is 2. Can we write 2 down? No, because it's in base 2. So what do? We use our division. 2. The base is 2. How many times 2 goes in 2? Is 1. What is left is what? Is 0. That's left, we write it here. What is here? We keep it here. Do you understand? From addition of whole number. Again, 1 plus 1 is what? 2. 2 plus 1 we keep is what? 3. So 3 in base 2. How many times 2 goes in 3? 1. What is left is what? 1. This one, we write it down and we keep this one here. Are we following? This is very important. Now, 0 plus 0, 0. 0 plus 1, 1. 1 is not up to 2, so we write everything down. So nothing is left here. Again, 1 plus 1 is 1. Is 2. 2 in base 2 is this. 2 in base 2 is 1. Left is 0. So we keep 1. 1 plus 1, 2 plus 1, 3. 3 in base 2 is 1, remainder 1. Since there is no other number again, what we keep here, we write it. This is called addition. And this is rough work. This is rough work, but it's very important. It's rough work. You can create it, no problem. It's very important. So which means the highest number we can see is 1. Because it's in base 2. Good. Let's look at another example. 1, 2, 3, 4, 5. 1, 1, 1, 1, 1. This is 1, 1, 1, 0, 1 plus base 2. Again, 1 plus 1 is what? 2. We cannot write 2 down because it's in base 2. So what do? With our division, if you like, 2 in base 2. How many times 2 goes in base 2? 2 goes in 2 is 1. What is left is 0. What is left? We let it here. This one is here, you can keep it here. If you like, you can come and keep it here. There is no problem. You can come and keep it here. 1 plus left, you can keep it here. Now, 1 plus 1 plus 1 is what? 3. So, 3 in base 2. How many times 3 goes in 2? Is 1. What is left is 1. What is left? Right here. What is goes? Keep it here. So, if you keep it down or you keep it up, it's okay. Again, 1 plus 1 plus 1 plus 1 is 3. 3 in base 2, 1. Left, 1. Right, 1. This one, right? 1 plus 1, 2, plus 0, 2. So that is 2 in base 2. 2 goes in 2, 1 times, left is 0. After that it goes 1 plus 1 plus 1 is 3. 3 in base 2 is 1. Left is, so we write this 1 down, and then since there's no other number, we write the last. This is in base 2. It's good to write it there to show that it's base 2. Do you understand? The highest number we have must be 1. Now, subtraction. How do we do for the subtraction? Just the same knowledge we have in whole number. We minus. If it's not possible, we borrow, right? We borrow from the next number, and what we borrow become base. In binary, in the whole number, it become 10, right? But here it become 2 because our base is in 2. This is what you did not take away you were in primary school. 1 is 0, 1, 1 is 0, 1. Base 2, that is for this, and this is 1, 1, 0, 1, 1 minus base 2. Now let's start. 1 minus 1 is 0. Base 2. Okay, this is now is 0 minus 1. Is it possible? It is not possible. What do? We borrow 1 from here, right? If you borrow 1 from here, let me use another pen. Okay. Now, if you borrow 1, from here, what is left is what? Is 0. That 1 becomes base, and the base is what? 2. So that one becomes 2. So 2 plus 0 is what? 2. So what I write in blue color are what to borrow, what comes for the other side. Again, 0 minus 1 is not possible. We have to borrow 1 from the next number. If it's not possible, you go to the next. If it's not possible, go to the next. If it's not possible, go to, until you see where to borrow. Good. So when you borrow 1 from here, what is left is what? Is 0. That 1 becomes the base. If the base is 7, the 1 becomes 7. If the base is 100, the 1 becomes 100. If the base is 1 million, the 1 becomes 1 million. But because the base is 2, the 1 we borrow becomes 2. So 2 plus the 0 is what? 2. So this is gone, and what is left here is 2. Now let's just check now. 2 minus 1 is what? 1. It's easy. Now, right? It's easy. Let me use the same color. It's easy now. Now again, 0 minus 0 is 0. This is easy. 0 minus 0 is 0. 1 minus 1 is 0. 0 minus 1 is not possible. Again, you go and borrow. If you borrow 1 from here, what is left is what? Is 0. That one we borrow becomes base, which is 2. So 2 plus 0 is 2. So 2 minus 1 is 1. What is left is what? Is 0. So there's no need of writing this now. Since it's 0, it's useless. Okay? I'm using black pen. Let me use black pen. So the answer is 1, 0, 0, 1, 0 in base 2. You see? When you're adding, it's not the same when you're subtracting. So be careful. Let's do one more example to make it clearer. This time we have 1, 1, 0, 0, 0, 0 in base 2. 1, 1, 1, 0, 1 minus in base 2. Minus. Don't forget, minus. 0 minus 1. It's not possible, right? What do? We borrow 1. Can we borrow 1 from here? It's not possible because it's 0. Can we borrow 1 from here? It is not possible. Can we borrow from 1 from here? It's not possible. We have to come and borrow from this place. This is a very interesting question. We have to borrow from this place. If you borrow 1 from this 1, what is left is 0. That one you borrow becomes the base 2. That 2 comes to this place. This place changed to 2. But this is not where we are going. We are going to this place. So we have to borrow 1 from this place. If you borrow 1 from this place, what is left here is what? 1. Again, you borrow 1 from borrow. The 1 you borrow comes here. This becomes 2. But this is not where we are going. Again, you borrow 1. That one becomes 2. Again, you borrow 1. That one becomes 2. Now we have reached our destination. So this is where we are not going anywhere again. Now it's easy. You see? Very easy. You borrow. Again, you borrow. Anytime you are borrowing, the borrow becomes the base. If the base is 4, the borrow becomes 4. Please keep it in your medulla oblongata. Now, let us see whether it's easy to do subtraction. 2 minus 1 is 1. 1 minus 1 is what? 0. 1 minus 1, 0. 1 minus 0, 1. It makes life easy. Now, the 0 minus 1. Again, it's not possible. What do? We go and borrow 1 from here. We borrow 1 from here. What is left is 0. That 1 we borrow becomes 2. That 2 comes here. We have 2. So now, 2 minus 1 is what? 1. What is left here is what? 0. 0, we don't write it. So that is, the answer is 1, 1, 0, 0, 1 in base 2. That is very interesting. Any base you are working on, the number must not pass that base. Keep it in. Keep it in. Are we together? Good. Let's go to multiplication. We have 1, 0, 1, 1, 1. In base 2, multiplication. Just the way we multiply. 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. Again, 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. So what do? We now plus, right? The plus. So let us add. This is 0, right? So 1 plus 0 is 1. It's not up to 2. Is 0 plus 1 is 1. It's not up to 2. 1 plus 0 is 1. It's not up to 2. I want to state it as 1. So answer is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 in base 2. Multiplication looks so easy, but multiplication leads to addition, right? So you multiply and you add. Good. The last question in multiplication. 1, 1 is 0. Let me shift my hands a little bit. 1, 1 is 0, 1. 1, 1, 1. Multiply. Multiply. Don't forget they are all in base 2, right? Now, 1 times 1. 1. 1 times 0. 0. 1 times 1. 1. 1 times 1. 1. We finish the first one. Second, 1 times 1. 1 times 0. 0. Times 1. 1 times 1. 1. The last one. Again, yeah. 1 times 1. 1 times 0. 0 times 1. 1 times 1. 1. And now we can plus. You see why I shift my hand here? Because I know that it's coming inside. Mathematics is very sweet. It's very sweet. Tell your neighbor, say, math is sweet. Okay, let's add now. This is what? 0 is 0 is here, so this is what? 1. 0 plus 1 is 1. We write 1 because it's not up to 2. 1 plus 0 plus 1 is 2. Can we write 2 down? No. What do? We divide. Let me do the rough work here. So 2 in base 2, 1, remainder is 0. So we write remainder and we keep the remaining 1. Again, 1 plus 1, 2, plus 1, 3. Again, we cannot write 3 down, so we have 3 base 2, 1 remainder 1. So we write 1, 1 left. 1 plus 1, 2, plus 1, 3. 3 in base 2, 1 remainder 1. 1 plus 1, 2. 2 in base 2, 0, 1. So the answer for this guy, they're all in base 2. Okay? Is 1 is 0, 1 1 is 1. It's interesting, right? Now the last part, division. 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 As usual, the way we divide. 1 1 1 1 1 1. 1 1 in 1. Is it possible? No. It's not possible. 1 1 in 1 1 is what? 1. Write it at the last number, just like what we did before. Long division method is very important. It's very, very important. So now multiply. 1 times 11. Don't call it 11. Call it 1 1. 1 times 1 1 is 1 1. Minus this one goes. Right? That's 0 0. You drop 1 down, right? You drop, if you like, you can write 0 0. So you put the next one down, right? For you to understand this concept, you must understand what we did in basic operation of whole numbers. If you have not catch it, please go straight and go and check it before you do this, okay? So that they make life easy for you. Mathematics is foundational, step by step. You cannot jump. You have to learn step by step. Okay, let's continue. So 1 1 and 1 is not possible. So multiply it is 0 1. So minus. So you drop the last 1, right? You only 1, you drop it. 1 1 in 1 1 is 1. 1 times 1 1 is 1 1. It's finished. So which means 1 1 1 1 in base 2 divided by 1 1 in base 2 is equal to 1 0 1 in base 2. You know what I did here? I tried to prove this. You see? 1 1 1 1 1 1 1 1 divided by 1 1 1 1 is what? 1 0 1 1 0. I use system to prove what I did here. So if I not get this result, it means something is wrong. Is either here or here. But this one, I did not do this one, right? So I don't get, so I don't look at the answer from here. I know what I'm doing. Question. We have some question on addition, subtraction, multiplication. Now, division. First one is okay, it's clear, right? Now let's look at the second question. Division. Okay, divide 1 is 0, 1 1 is 0, 1, 1 is 0, 1. Now let's go. How many times 1 is 0, 1 goes in 1? Not possible. 1 is 0, 1 goes in 1 0. It's not possible. 1 is 0, 1 in 1 is 0, 1. 1, right? Make sure that you write it at that point. Please, this is very important. You see? It should be at that point. Now, 1 times 1 is 0, 1, and it's 1 is 0, 1. So you minus, obviously this will be 0, 0, 0. So what do? You drop 1. How many 1 is 0, 1 you can see in 1? It's possible. It's 0. Drop the next number, 0. How many 1 is 0, 1 you can see in 1 0? It's not possible. So of course you can be repeating it. So drop the last one. So how many 1 is 0, 1 you can see 1 is 0, 1? 1. So which means 1 is 0. I do it short. Otherwise you could have been writing it like this. 0 minus 0, you will be repeating it. So 1 is 0, 1 is 0, 1 in base 2 divided by 1 is 0, 1 in base 2. It gives us what? 1 is 0, 1 in base 2. If you multiply this guy by this guy, we must get this back. Okay? Good. Now, let's look at basic operation for octa. I told you we have 4 important ones. We have base 2, we have base 8, octa, we have base 10, decimal number system, which we have done in old numbers, so I'm not going there. So go back there and go and watch the video, okay? And I'm going to do basic operation on hexadecimal. Hexadecimal, base 16. Remember? Last video, right? Good. Good. Now, we have been working with binary. Now, let us work with octa. Octa is what? Base 8. Now, when we are dealing with base 8, it means it contains only number from 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. No number more than 7, right? So let us keep it here. Now let's start. We have 6, 5, 4, 4, 0, 7. Addition in base 8. In base 8. It's very important. 4 plus 7. It's what? 11. Can we write 11 now? No. So we have to take 11 to base 8. So how many times 8 goes 11? Once. What is left is what? So I have to minus this, right? What is left is 3. That remainder, you write it down. This one, you keep it here. Or you keep it here. Doesn't matter. This is very important. This is rough work. You can delete it. Now, 1 plus 5, 6. 6 plus 0 is 6. Is 6 up to 8? No. So you can write everything down. And no remainder. Now, 4 plus 6 is what? 10. Can we write 10 down? No. What do? We take 10 to base 8 because it's in base 8. So how many times 8 goes in 10 is 1. What is left is 2. What is left, we write it down. Now, there is no other numbers, right? So this one, we can now write it here. Which means this guy plus this guy is give us this guy in base 8. Which means the number must not more than 8. It should be 7. The second question. 3, 7, 2, 7, 7, 7, base 8, base 8. 2 plus 7, they give us 9. Can we write 9 down? No. Why? Because it's more than 8. So we write 9 in base 8. How many times 8 goes in 9? 1. What is left? 1. What is left? Write it here. What goes? Write it here. 1 plus 7, 8. 8 plus 7 is what? 15. So 15 in base 8, because we cannot write 15 now. So 15 in base 8. What give us? 1. What is left? 7. Right? 7. So the remainder, we write it here. This, we write it here. Now, 1 plus 3 is 4. 4 plus 7 is 10. 10 in base 8. How many times 8 goes in 10? Just once. What is remaining is 2. What is remaining? I write it down. Since there is no number again, I can write the remaining one here. And don't forget, this is addition. Are you getting me? This is a mental work. And this is exactly what we did in base 10. That is the operation of whole numbers. Okay? Super. Now, subtraction. If you like, we can remove this rough paper, rough work. Doesn't matter. Now we have 7, 0, 4, 6, 2, 5, negative. Base 8, base 8. Remember? Borrow, right? 4 minus 5. Is it possible? It is not possible. We have to borrow from here. Can we borrow from here? It is not possible. We have to come and borrow here. If you borrow 1 here, what is left? 6. That 1 becomes what? The base. We are in base what? Base 8. So that one becomes 8. So you have 8 with the 0, we still have 8. Now 8 minus 2. Oh, we have not reached. We are coming here. Again, we borrow 1 from here. What is left is 7. That one becomes 8. 8 plus 4 give us what? 12. 12. Now, since we have reached where we are going, we can now say 12 minus 5 give us what? 7. What is left here is 7. So 7 minus 2 is what? 5. And then what is left is what? 6. So 6 minus 6 is what? Is 0. So if I like, I write it there. If I like, I don't write it there. So 6 is the last number. We may not write it there. And answer is 57 in base 8. Base 8. The second question. 6 is 0 is 0. 7, 3, negative. In base 8, in base 8. 0 minus 3. Is it possible? No. What do? We borrow from here. Can we borrow from here? No. We have to come and borrow from here. So if I borrow 1, what is left? Is 5. That one becomes base, which is base 8. So that one becomes 8. 8 plus 0 is 8. Again, I borrow 1. From this 8, what is left is 7. That one becomes 8. Add it here, we have 8. Now, 8 minus 3 is what? 5. 7 minus 7 is 0. What is left here is 5. Nothing is here, so that is 5 minus nothing. That is what? 5. So, answer is 505 in base 8. Do you see how it works? It's very easy. It's the same knowledge we know. But now, we are working with base 8. Let's go to multiplication. 2, 7 by 13. Don't forget, we are in base 8. Good. 3 times 7, 21. Are we going to write 21 down? No. We have to take the 21 to base 8. Anything we are doing is 8. So we have to take the 21 to base 8. 21 to base 8. So how many times 8 goes in 21? 2. What is left is what? 2, 16, that is 5. Don't forget, if you multiply this by this, add with this, you give us this. Remember? In the last video, right? Some videos before. I don't really know precisely, but we do something like this. So, this and this is 16 plus 5 is 21. So, you know that you're right. Now, what is left is what? 5. 5. So, we are keeping these 2, right? Keep it. Now, 3 times 2 is 6. 6 plus this 2, 8. We are in base 8. Are we going to write it down? No. We have to take it to fraction again. 8 in base 8. 1 remaining 0. What remaining is 0. Let me use the same pen. 0. We are keeping this, but there's no other number. So what we are keeping, write that. You see, very interesting, right? Now let's use 1. 1 times 7 is 7. It's now to 8. So 7. 1 times 2 is now to 8. So we write 2. And we sum it. Don't forget, they are all in base 8. Don't forget that. So this is 5 plus 0 is 5. Is 0 plus 7? 7. If you like, if you know it's confusing, please remove it. So be careful. Just know that it's base 8. 2 plus 1 is 3. It's not 8. So this guy plus this guy times this guy gives us this guy. the last multiplication. 4, 0, 6, 45 times. Don't forget we are in base 8. 5 times 6 is what? 30. Can we write it down? No. No. What do? We take 30 to base 8. How many times 8 goes in 30? That should be 3, right? 3. Remainder. To know the remainder, I can say this and this is 24. 24 minus this is 6. So the remainder will give me 6. Just have to think. So that if I multiply this by this plus this must give me this. So which means 6 is what is left. I write 6 and I am keeping 3. I am keeping 3. Keep it in your medulla. Now 5 times 0 is 0. Is 0 plus this 3. That's what? 3. Again, 5 times 4, 20. Are we going to write 20 down? No. We have to take 20 to base 8. 20 in base 8. How many times 20 goes into base 8? 2. Left is what? 4. So what is left? I write it down and I'm keeping 2. Since there's no other number, I can write 2. The last part. 4 times 6. That is 24. I can write 24, right? So I have to take 24 to base 8, which is what? 3. What is left is 0. That is 0. I write it down. I'm keeping 3. 4 times is 0 is 0. 0 plus this 3 is 3. 4 times 4 is 16. Can I write 16 down? No. It's bigger than the number base. So I have to take 16 to base 8. If I take 16 to base 8, how many times 2 goes in 60? Is 2. What is remaining is 0. I write 0 down. I am keeping 2. No other number. So the 2 I'm keeping, I can write it down. Next is what? Sum it up. Don't forget we are in base 8. So 6 plus 0 is 6. 3 plus 0 is 3 because they are not up to 8. 4 plus 3, 7 is not up to 8. 2 plus 0 is not up to 8. And this is 2. So the answer is 22736 in base 8. The base of the subscript. Don't go and write 8 like this. This means something different. Okay, please. Be careful. Okay, good. Now let's continue. We have finished the multiplication. Now let us look at division as usual. Right? Please keep in mind we are in base 8. Okay, so how many times it goes? 2 times 13, that is 26 minus, don't forget we are in base 8, so 7 minus 6, 1, 3 minus 2 is 1. Now we drop 1, we drop 5, right? Just like what I've been doing before. We drop it down. Now, how many times 13 goes in 115? We have to think very well here. Let's try 6. Can 6 goes? No. 7. 7. 13 times 7. This is 20, 21. 21 in base 8. That is 2 remaining 5, right? 2 remaining 5. So we write 5 remaining 2. 2 times 7. Sorry, 7 times 1, 7 plus 2, 9. 9. 9 in base 8, 1, remaining 1, 1, 1. Good. 7 times. 7 times. 7. So 7 times 13 gives us 115. Okay? So it means that oh, means that 375 in base 8 divided by 13 in base 8 is equal to 27 in base 8. 27 in base 8, which means if you multiply 27 by 13, we will get this back. You see what I'm here? 27 plus 13, that times 13, give us this back. I got it. I know your mind is not there. Okay, the last question. Good. So, the last question for this wonderful octave. Don't forget, octave means is 8, right? So, how many times 64 goes in 1? Not possible. In 16, not possible. In 162, obviously, is 2, right? So, 64 times 2. 64 times 2. Don't forget, we are in base 8. 2 times 4 is 8. So, 8 in base 8 is 1. What is remaining is 0. So, you write a regular, right? Now, 2 times 6 is 12. Plus this 1 is 13. Now, 13 in base 8. That is 1. What is left? 5. 5. And please always check it back. This times this plus this must give us this. Always. So that you know that what you have done is correct. So this times this 18 plus 5 is 13. Okay? So 5 is what is left. 5. Since there's no number again, I write the remaining one down. So that is 150. So 150 minus 2 minus 0 is 2. 6 minus 5 is 1. Is 0 minus 1 minus 1 is 0. Okay. Now we drop the next number. So we drop 4. Right? If you like, you can put out to 4. Now 64 in 124. Obviously, every 1. Because this double of this cannot give us this. 1. 1 times 64. 64, right? Nothing change. Now minus 4 minus 4 is 0. 2 minus 6 is not possible. We have to borrow 1 here. That 1 becomes 8. Don't go and say 10. We are base 10, we are base 8. Become 8. So this one becomes 0. Let's do it mentally. It's 0. So 8 plus 2, 10. Right? Now 10 minus 4 and minus 6 is what? Is 4. And what's remaining is 0. Do you understand that? Again, quick. You borrow 1 from here. The 1 becomes 8 because it's in base 8. So 8 plus 2 is 10. 10 minus 6 is 4. What is left here is 0. Because we have borrowed this 1. Now drop the last number. The last number. So how many times 64 goes in 404? 404. That's the count, right? 404. How many times it goes? Now we have to think. 10 times, it's not possible because 10 times will be like 6. Half of it can be, right? So that is 5. Let's say 5. Let's see 5. If 5 can go. Let's check it, of course. 64 times 5. We are in base 8. 5 times 4 is 20. 20 in base 8 is 2. Remainder 4, right? Let's check it. 2 times 8 is 16. 16 plus 4 is 20. Is correct. So we write 4. We are keeping this one. 5 times 6, that is 30. 30 plus this 2, 32. 32 in base 8. How many times 8 goes in 22? That is 4. That is 4. Remainder is 0. Remainder is 0. Let's check it. 4 times 8 is 32 plus. So that is 0. There's no number again. We're at 4. So which means you go there without any stress. So 5 times 64 will give us 404, which means it's finished. So we can say 16244 in base 8 divided by 64 in base 8 give us what? 215 in base 8. And that is finished. If you multiply this by this, we're going to get this back. I know you are looking at my hand, but I will point at this place now. It's not from here. It's not from here. And that is the end of octal number basic operation. And the last but not the least, look at this, hexadecimal. Let's go there. Good. Now we are at the last aspect of number system. Wow, number system have taken a lot of our time. So basic operation of number system, but now we are now in hexadecimal. What is hexadecimal? Hexadecimal a number from 0 to 15, right? Because it's base 16. So which means, let me write the numbers we need down because we are going to do use of it. We need 0, 1, 2, up to 9, and then A, B, C, D, E, and F, right? Meaning that A represents 10, 11, 12, 13, 14, and 15. Whatever this, right? If you are saying how, please check our previous video. It's very important. Good. Now, let's start. The first question is F6, D, and B plus 4, A, 9. Okay? Now, don't forget we are in base 16. So B plus 4. B is what? 11. So that is 11 plus 4, which is what? 15. Can we write 15 down? No. What is 15? F. So instead of writing 15, we can write F. D plus A. What is D? D is 13. A is 10. 13 plus 10, 23. Can we write 23 down? No. We have to take it to what? Base 16. So we have 23 in base 16. How many times 16 goes in 23? 1. What is left? 7, right? Let's check it. 16 times 4 is 16. 16 plus 7 is 23. So it's correct. So we write 7. And this one, we keep it here. Now, 1 plus 6, 7. 7 plus 9, 16. Are we going to write 16 down? No, because 16 is up to 16. So we have to take 16 to base 16. How many times 16 goes in 16? Is 1. What is left is 0. That is 0, we write it down. This 1, we keep it. 1 plus F. F is what? 15. 15 plus 1, 16. 16 in base 16. 1 remaining is 0. We write it 0, we keep 1. But there is no number again. So the remaining 1, we can write it down. So the answer is 1007F in base 16. Very interesting. Boy minus if. So boy minus if. Don't forget this is 0. Okay, this is 1. Not I. There's no I here. And there's no O here. Okay. So don't forget we operate this as 0 and this is 1. Don't forget we are still in base 16. F minus E. Is it possible? No. Because E minus F is not possible. E is 14. F is 15. You cannot minus 15 from 14. So what do? We start to get borrow, minus, borrow. Like some countries, you borrow money too much. I don't want to mention any country. Okay, don't crucify me. So we borrow 1 from 0. Is it possible? It's not possible. Let's go and borrow 1. You borrow 1 from A. You borrow 1 from A. What is left is, you borrow 1 from B. What is left is A. Right? That one becomes 16. 16 plus 0 still 16. Again, we borrow 1 because that's not where we are going. So if we borrow 1 for 16, what remains is 15. That one becomes 16. 16 plus E. That is 16 plus E. E is what? 14. 14. That is 30. So this goes, what is left is 30. Now, 30 minus F. What is F? F is 15. So 30 minus 15 is 15. So instead of writing 15, I will write what? F. This is very interesting. Let's see how we are playing around with number. F. What is left here is 15. 15 minus 1, that is 14. Are we going to write 14? No. We write what? E. And last but not the least, what is left here is A. A minus 0 is 2. Okay? Now, multiplication. A times 9. A is what? 10. So 10 times 9, 90 in base 16. In base 16. That is 90 in base 16. How many times it goes? 5 times. Remaining what? 10. 10. And 10 is what? D. So we write A and we keep 5. Now we are keeping 5. Good. See? F times 9. F times 9. F is what? 15. So 15 times 9 will give us 50. 57. Don't forget in base 16. In base 16. 57 in base 16. Now, plus the 5 we are keeping here. That is 5 plus 7. That is 12. What is 12? 12 is C. And this is 8. So we have 8C. So if we have 8C, we write C and we keep 8. So we are keeping 8 now in our medulla oblongata. Now let's continue. 9 times 1 is 9. 9 plus 8. What is 9 plus 8? 17. 17 in base 16. 1 remaining 1. This one, we write it and we are keeping this one in our brain. Let's continue. F, which is 15, times 9, just like before, that is 87. We are keeping 1 before, right? Plus 1, that is 88. Don't forget, this is in base 16. 88. What will you do? We write 8 and keep 8, but no other number. So we write all the 8 down. Are we together? We are together with your hand. Good. We finished the first part. Now let's go to the second part. F times A, that is 15 times 10, which is 150. 150 in base 16. 150 in base 16, that is 9, remaining 6. Multiply this by this and plus this, you will have this. So we write 6 and we keep 9. We are keeping 9, right? Now, F times F, meaning 15 times 15. 15 times 15 in base 16. 15 times 15 in base 16, that will be F1. Sorry, E1. E1. E1 plus this 9 we are keeping. Plus 9. That is 10. And 10 is what? A. E. So So we write A. So we write A. We keep E. We keep E. We are keeping this E. Good. Where are we? 1 times F is F, right? And F plus E. F plus E. What is F? F is 15. E is 40. That is 29. 29 in base 16. How many times it goes? Just once. So minus this guy, we have 13, right? And what is 13? 13 is D. So we write D and we are keeping 1. We are keeping 1. Again, F, this and this, this and this. Yes, F times F again. F times F, we have it up before, is E1. E1. We are keeping 1 before. That is E2. That is E1 plus 1, E2. So, no other number, so we can write E2 down. Now, we can sum everything. We can sum everything. Okay? So, this is A, no problem. C. C is what? 12. 12 plus 6. That is 18. 18 in base 2, 1, remaining 2. We write 2, we keep 1. We write what we keep. We keep 1. Right? If you like, you can keep it here. These are rough work, but they are very important. Where are we? 1 plus 1, 2. 2 plus A. A is 10. So 2 plus 10 is 12. And 12 is what? C. C. Okay. 8 plus D. 8 plus D. D is what? 13. So 8 plus D will give us 21. 21 will be 16. That is 1 remaining 7. Right? No. That is 16 minus, that is 5. That is 5. 16 times 1, 16. 16 plus 1, plus 5 is 21. So we have 5. Now we are keeping 1. So 1 plus 8 is 9. 9 plus 2, 11. And 11 is what? B. And this is the last one, B. And that is the end of this problem. We have to be careful. B60, every time B60, B60. Okay, the last part, division of numbers. 218A9 2D in base 16. Good. So 2D in 2 is not possible, right? 2D in 21 is not possible. Now 2D in 218. Divide this guy. What is left is B. Okay? So B, how do we get it? Of course, 2D 2D divided by 182. What's remaining is P. What is here, we don't need it for now because we have to multiply this by this. Okay? So 2D times B. 2D times B, that is D, 13 times 11. And what we have, multiply these two together, we have FE1. Okay? We have FE1, of course, we can check it, quickly check it. G is 13, B is 11, multiply it, That is 3, 1, 3, 1. That is 3, 4, 1. Right? Take it to base 16. We get this. Okay? So what we have here is 1 EF minus, right? 8 minus F is not possible. We have to borrow 1 from here. When we borrow 1 from 1, what is left here is 0. Let us do it mentally. So we have 18. So 18 minus F. 18 minus F. 1 becomes 16. 1 becomes 16. Let us write it down so that we don't make a mistake. 1 becomes 16 plus 8. That is 24. 24 minus F. F is what? 15. This is 1. We borrow 1. That is 9. What is left here is 9. What is here is 9 is 0. Right? Borrow 1 from here. This one becomes 1. So this one will go. So 1 becomes 16. 16 plus 0. No, 0 here. 16 plus 0. 16. So 16 minus E. E is 14. 16 minus 14. That is 2. That is 29. 29. You don't really call it 29 because we are in 16 base, not in 10 base. Now what do? You drop 1. You drop 1. Now 2D in 29A. 2D in 29A will give us E. How? Just divide it the way we divide it. Okay? Now multiply this guy times this guy. 2D times E. So 2D times E, 2D times E, that is D times E, that is D, 13, E, 14, and that will give you 672. Okay? Check it out. So 672, so we have 276 minus, now let's minus it. A is 10. 10 minus 6 is 4. 9 minus 7, this is easy, is 2, right? 2 minus 2 is 0. This is 0. And finally, we drop the last line, which is 9. So 2D in 24D. 2D in 24D. So divide it. And if you divide this guy by this, we have D. To cross check, you multiply 2D by D. And we see we get 276. Right? D times D. That is 16 in base 16. 2 times D times 2. That is 12 times 2, 24 in base 16. We have this, and then you have 249, which gives us this. So finally, 218A9 divided by 2D will give us bed in base 16. Bed. Bed means where you sleep, right? I think it's the best place to stop, and that is the head of number system. Enjoy.